Hello, good afternoon students. Welcome to one more fabulous session with Infinity Learn, India's largest exam preparation platform. मैं हूं सुरेश अवारी, faculty of chemistry. How you all doing? Hi Ishita. Hello Vikas. Great. Good afternoon. With nice smiley. Great. How are you doing? Fine, fantastic. Great beta. Okay, in this journey of NEET 2025 preparation, I welcome all the students in this session, those who are preparing for NEET 2025, who completed grade 12 and preparing for a drop and aspiring NEET 2025, and also those students who completed 11th standard and stepped into 12th standard and in the race of NEET 2025. So, in the series of these lectures, every day we are coming up with a particular topic which includes grade 11 as well as grade 12. Henam, hello Richa Sharma, hello, good afternoon Sheshu. Welcome to all the students and really appreciate special welcome to the students who are regularly attending in the sessions. Vikas, Sheshu, yes, Ishita, Wanga, these are all students regularly attending. Great. In the previous sessions, we were talking about general organic chemistry. In this YouTube channel, we are providing all the lectures right from 12 o'clock afternoon and till evening 6 o'clock. Those lectures are given by our eminent professors from Infinity Learn, Physics, Chemistry and Biology, and you are preparing NEET examination for absolutely free. You need not have to pay anything, and please do subscribe our NEET channel and like these videos and share with your friends, so that those friends also getting advantage of it. Hai na beta? That's good. So in these sessions, in the previous week we completed a couple of topics in 11th standard and 12th standard. 11th standard GOC is going, we are sailing in GOC, and at 12th standard we are almost completed electrochemistry. In this week we are again in the GOC. In the GOC शुरू हम आइसोमेरिज्म खत्म कर लिया, अभी तो जनरल ऑर्गेनिक केमिस्ट्री में इलेक्ट्रॉन डिस्प्लेसमेंट किया, कल का जो सेशन में इंडक्टिव इफेक्ट किया, आज हम प्रेजेंटिंग रेजोनेंस. Okay, my dear students, please confirm, can you all able to hear me and see me? Please come. Yes, confirm with a smiley emoji, fiery emoji and like emoji. Hi Rohit. You have given a Telegram channel, you please join there so that you will be getting an update. And also we have given a Google Sheet so that you fill it, so that you will be getting an updates in that also. Hi Fatima, how are you? How are you? Rohit Kumbar, hi. Fatima is also regularly attending the class. Yes, Shishu. And what about Uttam? I can't see his Thanos hand. Hello Uttam, are you there? I'm fine, thank you Betty. That's good. आगे बढ़ेंगे. So in the general organic chemistry we were in electron displacement effect beta. In this electron displacement effect, what are the things we learned so far? What is the order of electronic displacement effects? If you remember, yes, electron displacement effects, we completed inductive effect, and we are present right now in resonance effect, and later we will be discussing about hyperconjugation. After that, electromeric effect. So what is the order? He went out today. Oh, Okay, today, okay, fine, no problem, Fatima, right. So, what is the order of these electronic effects? Steric effect ज़्यादा सबसे ज़्यादा effective है, then aromatic effect, then resonance, then hyperconjugation, then inductive effect. Yesterday we discussed these orders, and these two are not electron displacement effect, and these are the electron displacement effects, and electromeric effect is not given because that is a temporary effect. है ना बेटा? Okay, let us see, this is a short recapture of this. Inductive effect आपका क्या है? Inductive effect is a permanent polarization. Inductive effect हमेशा permanent होता है. Permanent polarization due to electronegativity difference, okay, across sigma bond. That's it, and it is the weakest and distance dependent. Use DNP rule बोला कल, and इसका application का वजह से आपको फिर भी मिलेगा. Whenever you just come across with general properties and deciding stabilities and acidic properties or basic properties, you have to see whether all the things are present or not. You know? So, when all the things are present or one or more things are present, you have to follow this order. This is the extract of yesterday's class. You know, Arhan, hi. Arhan is also a student. Appreciate every day you are joining. Great. That indicates commitment, dears. So, let us talk about resonance. What is the meaning of a resonance? If anybody knows it, don't say a definition, rather you say what do you feel about the resonance. Yes, one student told me a day a funny story about resonance. Resonance is a concept where सब बच्चों लोग को डर लगेगा. फिर resonance के बारे में कुछ बोलना पूछा. So, resonance is the concept, every student has fear about it. Yes, everybody has a fear about it. And please note down the same thing in your diary, and that is till today. आज से एक क्लास के बाद you will be so fine with resonance. I am going to promise you that you will do excellent with resonance. Resonance is actually a phenomena, right? What do you know about this phenomena? It's a simple phenomena where a simple structure, if resonance is a phenomena where a single structure of a molecule, I just want to discuss about the benzene structure, benzene. I just want to discuss a benzene. This is the structure of benzene. To discuss the structure of benzene, does this particular molecule, this particular structure explains everything about benzene? फिर भी between these two a double bond, between these two a single bond. Sir, why you make a double bond? Why you make a single bond? If you experimentally identify, experimentally study the benzene structure, the carbon to carbon double bond length is less than carbon to carbon single bond length. This is about the bond length. ये bond length का वजह से I have to draw the structure like this. I have to draw the bond structure like this. When it comes to the reality, the benzene molecule do not exist like this. This is wrong. To explain this structure, I have to draw one more structure. All bonds barabar hai. So, there are 6 carbon to carbon bonds where you can see. I want to draw one more structure, I can make a double bond here also. I can make a double bond here also. है ना बेटा? Hi Aditi Patel, hello. So this is a structure 1 and this is a structure 2. कौन सा structure सही है? कौन सा structure सही है? दोनों सही है. So that actually benzene do not exist alone like this. Benzene do not exist alone like this. Benzene exist ये दोनों मिलके एक हाइब्रिड स्ट्रक्चर होगा. This is called hybrid. This is called hybrid. है ना? So what I want to say, this is one structure, this is another structure, and this is a hybrid structure. So I am talking about resonance beta. Resonance is a phenomenon, resonance is a concept where one structure, more than one structure should be drawn. Is a drawing the structures in chemical bonding beta. Drawing the structures in chemical bonding. More than one structure has to be drawn to explain actual properties or all properties of the molecule. Okay. So these structures are called resonance structures. And this is what you call it as resonance hybrid. And drawing and proposing more than one structures, and this phenomena is known as resonance. We are not talking about resonance effect. I am talking about resonance. Hey kya? Nidhi, fine, hope you understand. That's good. Arahan, what about you? And just want to say, these structures are shown like this. This can be represented like this. This can also be represented like this. है ना? But you may think that these two are in equilibrium. गलत बात है बेटा. They are not in equilibrium. समझे? मेरा आवाज सुना दे रही क्या? Okay, Pandey. My dear students, please confirm is my voice is okay with you all guys. Ha. Everybody can hear. Omshi Pandey, you just refresh or you can check your audio settings so that you can hear properly. Yes, yes, everybody is feeling it's correct. Okay, right. So these are all called resonance hybrid. Resonating structures are also called as contributing structures. And they are also called canonical structures. Right? And actual structure, none of this structure can actually explains the overall properties of the molecule. Rather, the molecule actually exists as the hybrid structure of all proposed structure. ये hybrid में इसका properties होगा, इसका properties भी होगा. Are you getting or not? So this is called resonance hybrid. Actual molecule exists as hybrid. If you take a bottle of benzene, this is benzene, is a liquid. Okay, this is a liquid. People at childhood days, हम भी ऐसा सोच रहे हैं, in this benzene molecules होगा, ये benzene molecules में आधा molecule ऐसा होगा, आधा molecule ऐसा होगा, गलत बात है. So actually this is not about benzene. Actually the benzene exists like this. Got it? And this is not a reversible symbol, right? So these are not at equilibrium. Actually when you talk about the resonance, the phenomena of resonance is actually is a hypothetical, imaginary. Okay? When it comes to the reality, never exists. And this structure is represented like this structure is represented like this. Ishitas, fine. Sheshu, that's clear. So that resonance, हर molecule में resonance होगा, हर molecule में resonance होगा, नहीं होगा. Okay. So what is the condition of resonance? In today's class, we will be discussing about a resonance होगा, नहीं होगा. अगर होगा तो क्या क्या मेथड्स में होगा एंड वेरियस टाइप्स. उसमें ऑर्गेनिक केमिस्ट्री में आपका फ़ायदा है क्या, मॉलिक्यूल के प्रॉपर्टीज़ कैसा होता है, एवरीथिंग वी आर गोइंग टू डिस्कस. ओके, सो वी विल डिस्कस अबाउट मोर. सो व्हाट इज ओजोन, इसका मॉलिक्यूलर फार्मूला क्या, इसका मॉलिक्यूलर फार्मूला क्या, O3, राइट. सो इसका स्ट्रक्चर ऐसे बना देंगे, 3 डबल बॉन्ड वो, सिंगल बॉन्ड वो. इसका लोन पेज भी दिखाना यार. एंड मेरे को लग रहा है वही यू मेक ए डबल बॉन्ड बिटवीन दिस टू एंड सिंगल बॉन्ड बिटवीन दिस टू. You can also propose one more structure with ozone like this also. Actually ozone exists not like this or not like this. Actually ozone exists like, फातिमा, ये दोनों मिलके एक हाइब्रिड स्ट्रक्चर बनाओ. जब आप हाइब्रिड स्ट्रक्चर बना देंगे ना, उसमें एक स्ट्रक्चर में ये दोनों का बीच में डबल बॉन्ड और दूसरा स्ट्रक्चर में दोनों का बीच में डबल बॉन्ड. सो ए डबल बॉन्ड इज इनकम्प्लीटली प्रेजेंट. सो दिस इज हाइब्रिड. व्हेन यू ड्रॉ द हाइब्रिड स्ट्रक्चर ना, you need not show the lone pair of electrons. So this is how we draw the structures. Okay, not only one structure, many structures. I am going to tell the rules to write the resonating structure. समझ में आ रहेगा? Okay, आगे बढ़ो. Resonance है क्या? Now you understand what is the resonance, and we'll talk about the word delocalization. The resonance का जो condition है, delocalization. What is the meaning of delocalization? Okay, delocalization. Delocalization is just अंग्रेज में ढूंढना. इसका मीनिंग क्या, delocalized. Assume somebody of my friend is driving his bike and he fell down. He when admitted into the hospital, डॉक्टर बोले कि इसका शोल्डर बोन डिसलोकेटेड है. सर शोल्डर बोन कहाँ रहना है, शोल्डर इज लोकेटेड हियर ड्यू टू एक्सीडेंट. व्हाट हैपन बेटा, दिस शोल्डर इज डिसलोकेटेड फ्रॉम दिस प्लेस, है ना. दैट इज कॉल्ड, एक मिनट आई विल चेक. श्योरिटी మ్యూట్ అక్కడ. ఓకే, మ్యూట్ అయిపోయిందా. ఇది ల్యాగ్ వస్తుంది పిల్లలకి, అది నేను ల్యాగ్ వస్తుందంట పిల్లలకి. ఇప్పుడు నేను సెషన్ కూడా తీసుకుని వచ్చాను, అప్పుడు కూడా డిస్కనెక్షన్స్ అవుతున్నాయి నెట్వర్క్. మీరు టెక్ టీమ్ చెప్పండి, ఇక్కడ నెట్వర్క్
దీనిది ఏమి ఉండదు ల్యాగ్, 15 seconds ల్యాగ్ ఉంటుంది.
చక్రం తిరుగుతుంది అక్కడ.
అది వచ్చినప్పుడు నేను చేస్తాను.
ఓకే, చెక్ రైట్. ఓకే, hope you all can you able to see me, confirm, can you able to see me? Can you able to see me, everybody? Hello, yes, thank you. So delocalization. Delocalization means here you can see CH3, CH2, double bond, CH and CH2, CH, double bond, CH2, right? So this is the structure of but-1,3-diene. What is the hybridization of this? The hybridization of this is sp2, sp2, sp2 and sp2, है ना? sp2, sp2. What is the geometry of sp2? It is trigonal planar. So as this is delocalized sp2, it has, you see, check it here, I just want to draw its molecular structure. Hydrogen, 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 now as sp2, px, py, pz, 3 orbitals ना, sp1, p2, sp2 बन गया, और एक ऑर्बिटल है lie perpendicular to this, so wherever it carefully you observe CH2, CH, between these two a lateral overlapping is seen. This is called a pi bond. दिखाई दे रहे क्या? ये जो pi bond है ना, ये वाला है. Got it? ये वाला है. Carefully you see. This is the pi bond. I just want to show you the orbital picture. Orbital picture, right? So this is called a but-1,3-diene. Now what happened now? This is one p orbital, this is one p orbital, this is one p orbital. How many p orbitals are there? They lie parallel to each other like this. Understood? And carbon to carbon जो bond है ना, it is around less than 1.5 angstrom unit. What is the meaning of 1.5 angstrom units? Very small distance. So what happened? If you keep your 4 fingers, assume these are 4 p orbitals like this. Okay, you can't hold it for a long time because the fingers automatically touch because they are close to each other. Are you getting or not? वेदांत डेफिनेटली सॉलिड स्टेट का जो एनिमेटेड वीडियोस के ना डेफिनेटली वी आर गोइंग टू प्रेजेंट विद दैट. ओके, डोंट वरी, वी आर हियर नाउ. Yes, so as this orbital are like this orbital are like this, these orbitals can join like this also. As a result, what happen? फिर भी और एक स्ट्रक्चर आपको देना चाहता हूं. कार्बन, they are going to give you now we can see this bond is detached here, this bond is detached here. Why don't they join and attach here और एक structure बना सकते हैं? Understand? So that what happened, this structure is converted into CH2, CH, CH, CH2. Now this bond is broken and came here, so that there is a bond. You can see that is the bond. Now when this bond is moving from here to here, देखो, moving from here to here, let it be. So you are going to get a negative charge, positive charge or negative charge, or reverse is also possible. So the bond was here and this is dislocated and bond becomes here. So this what you call it as delocalization. This is a term that is called delocalization. Delocalization of the orbitals or pi electron cloud or p electron system. Are you getting or not? So these electron systems are localized and delocalized. If parallel orbital is waiting for it, it will go and touch that. It is delocalized karega. Or otherwise, if nobody is there, the orbital will be like that only. That is called localized. Are you getting or not? Okay, Fatima, no issues. Is my voice or and video is getting any lag? Any lag? Please confirm, my dear students. Okay, you finding lag? You finding lag? Okay. Okay. Okay, fine. Let's go with this delocalization. Electron systems in the organic molecules are two types: delocalized system and a localized system. So localized system belongs to a particular region. So this is a pair of electron that is present on the nitrogen with this methylamine. In this methylamine, नाइट्रोजन का जो लोन पेयर है ना, ये लोन पेयर नाइट्रोजन के साथ ही रहता है, ये बाहर नहीं आता है. ओके, इट इज विथ नाइट्रोजन ओनली. सो इट बिलोंग्स टू ए सिंगल एटम. इसका नाइट्रोजन के पास है, सिर्फ नाइट्रोजन के पास है. अंडरस्टैंड? एंड कन्फाइनड बिटवीन बॉन्ड बिटवीन टू एटम्स, दैट इज कॉल्ड लोकलाइज्ड. इसका लोकेशन फिक्स्ड है, दैट इज कॉल्ड लोकलाइज्ड ऑर्बिटल्स. और दूसरा है टुडेज पार्टी इज अबाउट delocalized, है ना. सो वी आर गोइंग टू डांस हियर नाउ. नेदर बिलोंग टू, you see here CH3 CH डबल बॉन्ड एंड NH2. उसमें क्या हो रहा है? CH3 CH NH2, right? So that if you talk about this and the lone pair of electron present on the nitrogen, understand? And there is a pi bond between these. So this is actual structure of this. Are you getting or not? Understand or not? So what happened? This orbital are parallel, na? So they are going to touch. As they are going to touch, what happened? You are going to get, and the place is not here, इसका structure में यहाँ पर बना देंगे. CH3 CH and CH NH2, so that देखो ये जो इलेक्ट्रॉन है ना, इसका पास आने का कोशिश करता है. मैं बोला यू कैन सी दिस इलेक्ट्रॉन वांट टू कम, देयरफॉर देयर इज ए डिसलोकेशन. एज अ रिजल्ट ऑफ दैट, this electron is not located on nitrogen, it is located with carbon also. ये किसका ऑर्बिटल है? कार्बन का है. Are you getting or not? Some examples I want to give, Aditi, about localized and delocalized. यही है localized का, यही है delocalized का. Just अभी शुरुआत है ना. So पहले जो एग्जाम्पल है, बाद में सारा 4-5 एग्जाम्पल्स आपका देना कोशिश करता हूँ मैं. ओके बेटा. एंड माय डियर स्टूडेंट्स, सो जो लोन पेयर ऑफ इलेक्ट्रॉन ये नाइट्रोजन के साथ है, इट इज फिक्स्ड है. जहां पर इलेक्ट्रॉन का प्लेस वही एटम है फिक्स्ड होता है, इट इज का लोकलाइज्ड. आज का कहानी लोकलाइज्ड की वजह से नहीं है. ओके, सो आज का कहानी डिलोकलाइज्ड की वजह से है. सो दैट, सो व्हाट इज डिलोकलाइज्ड? जो नाइट्रोजन का इलेक्ट्रॉन देख रहे हैं ना, ये सिर्फ नाइट्रोजन के पास भी नहीं है, ये कार्बन के साथ जा रहा है. सो दैट इज व्हाट यू कॉल इट एज डीलोकलाइज्ड. यहां वहां घूमते रहते हैं डीलोकलाइजेशन में. ये घूमने का कहानी है आपका रेजोनेंस. किस तरफ घूमने हैं, किस तरफ जाना है, आते हैं जाते हैं. सो वाई, how many, everything you can discuss in the course of resonance. Are you getting or not? So delocalized, localized हर बार आप ऑर्बिटल ड्रा करके देखना है क्या? नहीं बेटा, सिर्फ आप पाई बॉन्ड देख के बोल सकते हैं, पी ऑर्बिटल देख के बोल सकते हैं, लोन पेयर देख के बोल सकते हैं. समझ में आ रहा है क्या? सो कैसे कर रहे हैं? So if the electron is fixed on a particular atom, it is localized, leave it normal. And if the electron is moving from one atom to another atom, that is called delocalized. Are you getting or not? These delocalized systems, how to identify that? So talking about now, after a 30 minutes of class, we are in the definition of resonance. We discussed the phenomena of describing delocalized moving electron, okay, in a molecule or ion or a free radical, जो भी species होता है, where bonding can't be expressed by a single Lewis structure. Single Lewis structure can't explain overall properties, all the properties of the molecule, so that ये single नहीं होगा तो दूसरा बनाना पड़ता है. Actual molecule exist कैसे है, कैसे करते हैं? ये पहला स्ट्रक्चर का है और दूसरा स्ट्रक्चर का है. ये पहला स्ट्रक्चर और दूसरा स्ट्रक्चर, यू कैन राइट फर्स्ट, सेकंड, थर्ड, 10. सो लाइक दैट मेनी स्ट्रक्चर्स यू ड्रा. एक्चुअल स्ट्रक्चर इज गोइंग टू एग्जिस्ट एज द हाइब्रिड ऑफ ऑल द प्रपोज्ड स्ट्रक्चर्स, एक्सप्रेस्ड स्ट्रक्चर्स और प्रपोज्ड स्ट्रक्चर्स. यही बात है, रेजोनेंस है. ये रेजोनेंस, each Lewis structure is contributing structure of a molecule. Contributing structures are not isomers beta, they are imaginary pictures. How? Why is that in a different language? You don't know. Hello? Who is that? Change your name. Okay, contributing structure, different the positions. I am going to tell you. These 2 points are very, very important. I'll come back with this. Okay? I'll come back with this. So when this molecule, her molecule, will go in a different method. Does every molecule show resonance? Condition क्या? कंडीशन क्या? पहला कंडीशन जो है, the molecule should be structurally planar. The molecule should be planar. जो structure है तो क्या? sp2 hybridized. It is a trigonal planar. The molecule is plane. Then only delocalization can happen. If the molecule is not plane, delocalization do not happen. What I mean to say, if the molecule is plane, two orbitals are like this parallelly, so they can overlap. So pi bond is overlapping and delocalization can happen with the other orbital. If the two orbitals like this, if this part of the molecule is one plane, this part of the molecule is another plane, they can't overlap, no? So the molecule should be planar. Okay, there should be delocalization. There should be delocalization. Conjugation should be present. Conjugation. Conjugation is very important. In these two, 1 and 2 points should be simultaneously applicable. Then only the resonance takes place. ओके, सो ए कॉन्जुगेशन है क्या? एक कॉम्प्लिकेटेड टर्म है? नहीं कॉम्प्लिकेटेड टर्म बेटा. मेरा साथ जो लेक्चर ले रहे हैं ना आप, ये आसानी भाषा में बोलना है, सिंपल. आपका कॉन्जुगेशन बाय सेपरेशन बाय only one sigma bond. This is what you call it as a conjugation. अगर conjugation होगा तो resonance होगा, conjugation नहीं होगा तो resonance नहीं होगा, बस. Okay, types of conjugated systems. I want to say, let's see here, CH2 double bond, CH single bond, CH double bond, CH2. You can see here pi bond separated by one sigma bond. So that is called pi conjugated system. Understand? Pi conjugated system. Any doubt? 307 users are there right now, but nobody is turning up in the chart. Come on, बुलाओ, आपका फ्रेंड्स भी बुलाओ. रेजोनेंस गर्मी टॉपिक है ये, गर्मी समर में, राइट बेटा? ओके, और एक एग्जांपल आपके पास, लेट्स से CH2 डबल बॉन्ड CHCl, यहां पर कॉन्जुगेशन है नहीं? चार्ट बॉक्स में बोलो जल्दी, yes or no. If yes, you type yes. If no, you say no. Chart box. I am searching in the chart box. Conjugation है नहीं है? Okay, Ishita, you said no. Okay, and what about Richa? Shesho, where are you? अरे this time I am really missing Uttam. Fatima, come on. Right, इसमें देखो, यस, एक पाई बॉन्ड है ना, एक सिग्मा बॉन्ड है ना, और कुछ देख रहे हैं क्या आपके पास? मेरे को देख रहे हैं यहाँ पर लोन पेयर ऑफ इलेक्ट्रॉन्स. सो दिस लोन पेयर ऑफ इलेक्ट्रॉन्स आल्सो प्रेजेंट. सो पाई बॉन्ड लोन पेयर आर सेपरेटेड बाय वन सिग्मा बॉन्ड. उसमें कॉन्जुगेशन है, उसमें conjugation है. Are you getting or not? Are you getting or not? Now you just say something here, CH2 double bond CH and CH2 and CH double bond CH2. उसमें conjugation है क्या? उसमें conjugation है क्या? conjugation है क्या? इशिता अभी बोलो, जल्दी जल्दी बोलो फटाफट. पाई सिग्मा सिग्मा पाई है ना? अरे टू पाई बॉन्ड्स आर सेपरेटेड बाय टू सिग्मा बॉन्ड्स, लेकिन हमको चाहिए सिर्फ और सिर्फ एक सिग्मा बॉन्ड है. अगर दो सिग्मा बॉन्ड सेपरेट करने तो उसमें कॉन्जुगेशन है नहीं. शिशु, सो whenever given molecule is seen, if you observe a conjugation, means separation by one double bond is called, that is conjugation. If resonance is, conjugation is there, resonance is there. If conjugation is not there, resonance is not there. उसमें resonance होगा, उसमें resonance होगा, उसमें resonance नहीं होगा. Got it बेटा? अरे simple, अरे simple, resonance is a simple concept. You only move around the concept and you don't know where to crack the nut and you only confuse. It's very simple phenomenon. Okay, it's very important to take a snapshot of it. Come on, 3, 2, 1. NEET आंसर की, अरे फ्यूचर डॉक्टर, NEET आंसर की का क्लास नहीं है जी. Okay, so what are the types of conjugation? Here pi bond and pi bond conjugation, here pi bond and lone pair conjugation. Okay, many types of conjugations are there. I just want to discuss about the types of conjugated systems. Okay, so electrons, delocalized electrons, I will tell you. Pi bond positive charge conjugation, pi conjugation, electron non-bonding electron conjugation, pi vacant orbital, negative charge and pi bond conjugations. Many types of conjugation systems are there. Let me exemplify what are the different types of conjugated systems. So, here we have CH2 double bond CH, CH double bond CH. Carefully observe, pi, sigma and pi. This is what you call it as pi conjugated system. Understand? Understand? Now, I have CH2 double bond CH Cl. In this case, this is a pi bond sigma bond lone pair. Can everything can see what I am writing there? बॉन्ड स्ट्रक्चर याद करना जरूरी है सर, प्राइम मिनिस्टर मोदी जी. So you don't have to memorize anything. Am I looking at anything and I'm drawing? No, सिर्फ simple stylus है मेरे पास. Okay, you just take the concept and apply the concept, तब पता चलेगा कैसे करना. हर बार रट्टा मारना अच्छा बात नहीं बेटा. ये नीट एग्जामिनेशन, वी आर डूइंग ए ग्रेट थिंग. ओके, इन दिस क्लासरूम definitely yesterday I simply say thank you and salute to the students. I have seen the comments also, and you have given a very good compliments during a class and at the end of the class. And we are in the journey of NEET 2025 preparation. In this preparation, eminent professors from Infinity Learn, we are teaching conceptual and NEET 2025 preparation. Afternoon 12 o'clock to evening 6 o'clock, physics professor, chemistry, me and biology professors are teaching a topic wise and completing and making you to write examination so fruitfully in projected अगले NEET 2025 examination के लिए. So please believe in us and make this program so successful and get benefit of this. That's why we are asking regularly you come to the class and do practice, join in Telegram channel so that आपका जो content दे रहा है ना, आपको content मिलेगा, updates मिलेगा. And please like this session, because we are doing a lot of efforts and you are also putting efforts, and bring your friends and share with your friends and subscribe to NEET STEP UP program. है ना बेटा? Yeah, not a problem, मोदी जी, not a problem. Okay, so यहाँ पर आपका पाई लोन पेयर का कॉन्जुगेशन चल रहा है, और एक कॉन्जुगेशन में आपको देना चाहता हूँ CH2 double bond CH and CH2 plus. In this pi bond sigma bond positive charge, so pi bond and positive charge conjugation is same. I can give you one more, CH2 double bond CH and CH2 minus, so that negative charge and pi bond is getting delocalized. That is called pi bond negative charge delocalization. Sometimes you can say CH2 double bond CH, CH2 जो free radical है ना, this is what you call it the free radical. This free radical also take in conjugation. So you can say it is pi bond sigma bond odd electron. So pi bond on odd electron conjugation है. So जो भी है, many things are there. I'll give you a simple trick. First of all, whenever molecule is there, conjugation है नहीं है, आप ढूंढना पड़ता है. Okay, sometimes your eyes are going to disturb you, sometimes your eyes are going to cheat you. So once you say always always, कहीं नहीं लिखा, always electron moves from high electron density to low electron density. Bas. You have a building residing in 5 floors and 12 floors and 15 floors, let it be. So when you open a tap, it is coming now. Why? Because overhead में water है. So always water comes from top floor to down floor. Water has more water potential and it is traveling towards less water potential. समझ में आ रही क्या? Similarly, during a resonance, electron always move from high electron density to low electron density. That is a mantra during resonance. Bas. You want to read and you want to get, hundreds of books are available in the Google, but एक ही लाइन में पूरा ढूंढना पड़ता है ना. Right, see, all clear बेटा. So order of electron density, order of electron density, नेगेटिव चार्ज का ज़्यादा होता है, लोन पेयर का ज़्यादा होता है, पाई बॉन्ड का ज़्यादा होता है, ऑड इलेक्ट्रॉन का ज़्यादा होता है, एंड पॉजिटिव चार्ज. दिस इज द ऑर्डर. बस. You want to read? Read it. That's it. Take a snapshot. Take a snapshot. 3, 2, 1. खींच लिया. Come on. Now in this case, how to apply this? How to apply this? Let me take this. Let me take this. 2 examples I will take. Now, what is the order I said? Negative charge, lone pair, pi bond, odd electron and a positive charge. ये है ना? This is only the order. Am I right? This is only the order. Am I right? In the resonance, सिर्फ एक ही चीज के लिए हमको डर लगता है. ये क्या? एरो मार्क्स की ना. एरो मार्क्स शुड बी गिवन इन विच डायरेक्शन. ये डायरेक्शन आपको बता देंगे. सो दिस इज द ऑर्डर. इलेक्ट्रॉन ऑलवेज मूव फ्रॉम हाई इलेक्ट्रॉन डेंसिटी टू लो इलेक्ट्रॉन डेंसिटी. लुक एट दिस CH2 double bond, CH and Cl. Right? What is their lone pair? This is your lone pair. This is your pi bond. This is separated by sigma bond. अभी उसमें conjugation है. समझे बेटा? conjugation है कि नहीं? Now electron should move from here to here or here to here. Tell me the direction. If this or this. आगे कदम रखना. You are going to start resonance का direction अभी. I want to see those students who want to say the chlorine to carbon electron बदलने वाले के 1 दबाव. Carbon to chlorine electron बदलने वाले से 2 दबाव in the chart box. Come on. I am just looking into the chart. अरे this is a YouTube lesson and it is a live lesson and this is not a radio transmission. Radio transmission में क्या होते हैं? हमेशा गाना सुनाने. Okay, so you never talk, only सुनना है. One way of transition, but here two-way transaction होना चाहिए. Shesho, you are absolutely correct. Richa Sharma, Ishita, wonderful. Now, it is said that lone pair का electron density ज़्यादा है pi bond से, so that always lone pair से pi bond तक electron जाना है. so that the electron should come like this, the electron should come like this. You understand? Clear? This is how the direction of the resonance arrow mark is decided in the chemistry. Got my point? Now इसमें अगर canonical structure देना चाहता हूँ CH2 CH Cl, this was the actual structure पिछले वाले के. As this electron is moving here, there will be a double bond, there will be a double bond, है ना, so that this lone pair of electron on the chlorine चले गया, so that this electron is coming on the carbon, so that this is removed. Are you getting or not? Now carefully you see, this electron is coming here, so that chlorine feel it lose its electron, it lose its electron. समझे बेटा? And this electron is coming on the carbon, therefore carbon feel it gain electron, therefore you generated charge, therefore you generated charge. Am I right? Understood? This is how resonance is written. Now this can be reversed, this can be reversed, can be like this, can be like this. I think you can see the color. I want to show the different color, I shown it. Yes, somehow it is visible, right? Okay, इसका resonance hybrid ऐसे होगा CH2 CH and Cl, you know. So there is no change in the position of atoms, and there is a double bond like character like this. There is a double bond like character. And the overall charge you are going to get here, it is partial positive charge and a partial negative charge. Got it? Clear? When you see this is the one, one more thing I can say as an example. Can I write one more example here itself? Can I write? हाँ, और एक क्वेश्चन निशांत, और एक क्वेश्चन मैं कुछ देना चाहता हूं. Elumalai, Risha, fine. Come on, let's see. If I write one more question here, CH2 double bond CH CH2. This is what you call it as allyl carbocation. Nishant, it's for you. Allyl carbocation. This is a pi bond. This is a positive charge. Pi bond and a positive charge, है ना? So electron always move from the pi bond to positive charge or positive charge to pi bond. Now here electron move from pi bond to positive charge. Previously, in contrast to that, electron is taraf guzra hai. Now in this, electron is moving in this way. Children, hope you understand. This class is a NEET STEP UP program, okay, medical entrance examination program. Ishita, I am giving the same repetition with a different example. Is that fine? Come on, right. So that you are going to get one more structure like this CH2 CH double bond CH2 like this. इसका resonance hybrid है CH2 CH and CH2. so that it is getting partial positive charge and a partial positive charge. So let us talk about the rules for writing resonating structures. जो भी नीट है, जो भी IIT जी में, okay, the concept of resonance is the same, Nishant. You don't have to worry. Safely you can be present here. Okay, just give a minute and study these questions and study these points. Okay, let's see here. Only electrons change their position but not the nucleus. What I mean to say, when you write the resonating structures, position of the atoms are not changed, position of the atoms are fixed. CH2 यहाँ पर है, CH2 यहाँ पर है. You don't change the position of the atoms. That's what. Position of the atoms are fixed. समझ में आ रही क्या? Right? हाँ निशांत. I am Dr. Suresh, our Faculty of Chemistry from Infinity Land. Introduced myself. Continue the lesson. Okay? Okay, come on. And the position of sigma bonds are fixed. I just changed the position of pi bond and a lone pair or a positive charge, whatsoever it may be, but sigma bonds position is fixed. हर पॉइंट का एक्सप्लेनेशन में दे रहा हूँ. ये पॉइंट ये स्ट्रक्चर में इस्तेमाल करो बेटा, आपको पता चलेगा क्या करना चाहता हूँ. ओके निशांत, होप यू आर अंडरस्टैंडिंग. यस. नाउ number of unpaired electrons and paired electrons remain the same. I'll give a proper example for this. Now उसमें ये स्ट्रक्चर में देखो, ये स्ट्रक्चर में number of unpaired electrons, let us say number of unpaired electrons. Here number of unpaired electrons means 3. यहाँ पर टोटल नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स कितने? ए पेयर है, ए पेयर है, ए भी ए पेयर है ना, इसका भी 3 है. Right? Number of unpaired electrons and the paired electrons remain the same, or the sum of these two are going to be the same. You can see number of paired electrons means number of bonds. Are you getting or not? Clear? Now total number of electrons in the species remains the same, then only this and this दोनों मिलकर आ जाएगा. Total number of electron species in the same, mean to say the sum of bond pairs plus lone pairs का. Okay, if you maintain this point, everything will be automatically fixed. Everything. Okay, position of atoms are fixed. Stick on to this. समझ में आ रहा है क्या? Great, nice butterfly. Butterfly in the stomach ishita. Okay, pi electrons and the non-bonding electrons change their position. Pi bond यहाँ पर था and it is moving here. So during a resonance, only pi bond or lone pairs is going to move without changing the structure of the molecule. ये resonance कहानी में. Risha, fine beta? Right. Only electrons change their position but not the nucleus. That's what I discussed. So these are the rules. Any resonating structure you want to draw, never deviate from these rules. If it deviate from the rule, gaya. ठीक है बेटा? Now let us see one more important point related to this. We have no real existence of resonance. Resonating structures, I said, they don't actually exist, they are hypothetical, or you can say simply imaginary. So students dear, please don't scold me as they don't exist. Why you are teaching, sir? Yes. Yes. Hi, who is that unknown? We have to learn this resonance to predict the possibility of the reaction, the possibility of the stability, the possibility of the activity, acidic strength, the basic strength, everything. This is used for prediction beta. ठीक है? So talking about and only movement of electrons is allowed, only the movement of electrons, only electrons बदलते रहते हैं, atoms नहीं बदलते, मैं बोला, right? And must be a proper Lewis structure, a structure, it should follow all the octet rule configurations. If anything out of this valence bond theory rules, na, the structure is not obeying resonance rules, so that you can't draw that. You are in the 12th. Okay, very good. It's my privilege. Who is that name? I can't see, given as an unknown beta. Okay, come on. All the atoms which are the part of delocalized system must lie in the same plane. ये essential condition है. ये resonance में शुरू होने के लिए पहले point देखना है. Those atoms, I mean to say the molecule should be planar and there should be conjugation. There are the 2 points as a trick I have given, my dear students. चलते बेटा? Come on. More stable structure, greater this contribution to the hybrid structure. So I want to say resonance we can draw so many structures. Okay, in those structures the one which has a more stability, how to predict the stability of the molecule? First of all, you need to see a charge delocalization and a charge separation. Okay, I will show that and I will give the order of stability, and writing this stability order is very important. You said you are unknown, but you said you don't remember me. How do I know beta? याद नहीं बेटा. Many of my students, their siblings are coming to my class. Okay, one day IIT Delhi से एक बच्चा आ गया था, इसका भाई आ रहे थे, and one day so I don't know your identity. How can I say how do I remember or not? Okay beta. Okay, let's go. So here 2 things. Complete octet वाला हमेशा stable होता है. Okay, resonating structures with more covalent bonds are more stable. Non-polar canonical form is more stable than polar canonical form. I'll explain this point. In case of incomplete octet or resonance, charge stability depends on electronegativity of the size. I'll tell. So when you read this kind of things, this point is very, very important. I'll come to this point after some time. Okay? Okay, come on. Let's see. Always I want to say in my word, charged neutral structure is more stable. More stable than charged one. What is the meaning of this? Short stories by me. Hello. I want to say this is CH2 double bond CH and Cl. Lone pair of electrons are seen. This electron is coming because the resonance is happening. When you see this structure, one more structure बना देंगे मैं, CH2 CH Cl plus. So ये दोनों structure में, ये structure 1 and the structure 2, ये दोनों structure में कौन सा structure stable है? This is a neutral structure. Neutral structure is more stable than charged one. I mean to say, this is the neutral structure. Stability 1 is greater than 2. समझे? 1 is greater than 2. Got it? Clear? Now, this is very, very important. And one more important, charge delocalization is more stable while charge separation is unstable. ये चार्ज डीलोकलाइजेशन है क्या, चार्ज सेपरेशन है क्या? आई एम गिविंग अ वेरी गुड इंपॉर्टेंट पॉइंट. हाँ, short stories by me. I am also giving the short stories in a long format. So 11th की बाद 12th is enough if I study consistently. My 11th is not that bad. If you see the analysis of NEET 2024, 11th standard and 12th standard is almost given equal priority in the weightage of question paper, children. That's why I just strongly recommend you be good in both 12th standard and 11th standard. Rekha, धन्यवाद, सबको धन्यवाद. Okay. Yes, if you see IIT examination and NEET examination, this class is especially for NEET students, a special batch, and we are giving an intensive hardcore program in this NEET. And you never miss any single point in the NEET perspective even. Okay, Rahman, that is MN3 plus MN2 plus वाला will be discussing in the NEET analysis और एक session है. रहमान, आपसे याद रखना मुझे सर, डेफिनेट. अरे आपका नाम आपका हमको कैसे पता चलेगा, अननोन का बेटा? अननोन बेटा. So don't say that. So my apologies. I want to call you with a lot of affection and love by your name, not calling unknown. हमको भी बुरा लग रहा है बेटा. Okay, come on. ये चार्ज डिलोकलाइजेशन है क्या, चार्ज सेपरेशन है क्या? Okay, so I'll give you a simple trick for that. Charge separation and a charge delocalization. So let's see. पहले क्या देना चाहता हूँ, एसिटिक एसिड CH3 C double bond O OH. This is acetic acid. Fatima, okay. No spamming, Risha, please no spamming. Okay, now this lone pair of electrons, you can see this is actually, it is eligible for resonance, so that it is participating. As it is participating in resonance, इसका दूसरा structure बना देंगे, so that this bond is going there and देखो, this electron is coming here ना, this electron is coming here ना, yes, this electron is coming here na, so that there will be a double bond, there will be a negative charge, right? There will be a negative charge. Okay, so there will be a negative charge, and as the electron is coming here, there will be a positive charge, so that the resonance is taking place like this. Lucky number 500 देख रहे हो total viewers. The 12 chemistry classes, melodies on Thursday, Friday, Saturday. 11 chemistry classes, Monday, Tuesday, Wednesday. Anirudh, अभी याद है. Anirudh, how are you beta? Now, what I mean to say, here a neutral molecule become a charged molecule. चार्ज यहां पर सेपरेट किया गया, so this is called charge separation. This is what you call charge separation. While you take और एक example है बेटा, एसीटेट आयन, दिस इज CH3 COOH का वो कहानी है, CH3 COO माइनस का वो कहानी सुना है, CH3 C डबल बॉन्ड O माइनस. अभी तो फिलहाल इसके पास चार्ज है, ये चार्ज घुमा घुमा के वो दूसरा एटम पर डिस्पर्स कर रहा है. सो इसी का वजह से ये वाला CH3 CO माइनस डबल बॉन्ड C. सो दिस इज व्हाट यू कॉल इट एज चार्ज. फिर भी ये आ रहा है, so that the charge is already there and the charge is dislocated from here to here. This is called charge delocalization. This is called charge delocalization. समझ में आ रहा है क्या? So this is the crystal clear picture about ये charge separation है क्या, charge delocalization है क्या. So charge delocalization अच्छा बात है and charge separation अच्छा बात कभी नहीं होगा. So charge separation जिस मॉलिक्यूल का स्टेबिलिटी कम करने का कर रहे हैं, लेकिन charge delocalization स्टेबिलिटी बढ़ने का कर रहे हैं. Are you getting or not, फातिमा? हाँ बेटा, come on. So that's what it is indicated here. और थोड़ा बहुत क्वेश्चंस कर सकते हैं. Great, 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 great. So let's see. Talking about canonical or resonating or contributing structures are theoretical structures. Structure which contain localized bonding electrons but can't explain the property of the entire molecule. Of course, resonance hybrid is a true structure. हमेशा true है. Structure which contain delocalized bonding but explains property of the molecule. So let's see comparison of the structure of the molecule. इसमें structure 1 दिया गया, structure 2 दिया गया, है ना बेटा? Carefully observe. But looking at the arrow marks, you please don't worry about what is happening. So clumsy structures only makes it headache. Don't look at the answer. वो दोनों में क्या क्या आंसर है. इसमें स्ट्रक्चर एक है, स्ट्रक्चर टू है. So let's talk about the stability of the structure 1 is more than structure 2. He is saying that stability is directly proportional number of bonds. उसमें number of bonds कितने? 1 2 3 4 5. 1 2 3 4 दिख रहे हैं. मेरा ख्याल से ये न्यूट्रल स्ट्रक्चर है. दिस इज चार्जड स्ट्रक्चर है. अरे न्यूट्रल स्ट्रक्चर इज ऑलवेज स्टेबल देन चार्जड स्ट्रक्चर बेटा. तभी भी ऑफ कोर्स अकॉर्डिंग टू दिस लॉजिक आल्सो दिस इज ट्रू, बट मेरे ख्याल से ये लॉजिक पकड़ना अच्छा होगा. ओके, दैट इज द स्ट्रक्चर ऑफ स्ट्रक्चर 1 इज मोर स्टेबल. एंड सेकंड स्ट्रक्चर, दिस इज द सेम. न्यूट्रल मीन्स पोलर, चार्जड मीन्स पोलर, neutral means non-polar. That's what I am saying. Carboxylic acid and it given its structure is a polar structure, is a neutral structure. Therefore, one structure is more stable than two structure. समझे बेटा? समझे बेटा? Right. And we can do many questions based on this. Simply identification of the stability of the molecules or the structures are very, very, very important. Let's talk about comparison of the structures. Yes. Don't look at the answer. Don't look at the answer. Okay. Now, carbon with a positive charge, carbon with a positive charge, oxygen with a positive charge. I want to give you a trick. This is actually a trap. This is actually a trap. Oxygen is more electronegative than carbon. So, positive charge is present on the oxygen. ऑक्सीजन इज मोर इलेक्ट्रोनेगेटिव, इसका ऊपर पॉजिटिव आना गलत बात है. सो दैट स्टूडेंट्स थिंक दैट स्टेबिलिटी O प्लस लेस देन C प्लस. This is wrong. Never look at the charge. Look at octet. Rule. Octet rule is greater than charge rule. Priority, preference ऐसे देना है. रेजोनेंस आप इस्तेमाल करके क्वेश्चन क्रैक करना चाहता हो, ये प्रायोरिटी फॉलो करना पड़ता है. मैं कल बोला था क्लास में कार्बोकैटायन का, याद है? कार्बोकैटायन, कार्बोनियन, कार्बन फ्री रेडिकल, कार्बोकैटायन. इफ यू रिमेंबर यू टेल मी. कार्बोनियन 8 इलेक्ट्रॉन इसका, कार्बन फ्री रेडिकल 7 इलेक्ट्रॉन इसका, कार्बोकैटायन 6 इलेक्ट्रॉन इसका. सो दैट ऑक्टेट इनसफिशिएंट है. ऑक्टेट इनसफिशिएंट है. कार्बन इज नॉट ऑक्टेट. यहां पर हाँ ऑक्टेट, यहां पर ये भी ऑक्टेट है. सो ऑक्टेट इज मोर स्टेबल, therefore structure 2 is more stable than structure 1. So give thumbs up, you all understand this particular question. Got it? हाँ, Abhinav. Crystal clear, right? Very good. Come on. Now this is CH2 minus, this is CH2 minus and O minus. तभी O minus carbon with a negative charge. This is octet. This is also octet. And this is octet. And this is also octet. Now octet is okay, then you change and compare the charge. If octet is not checked, you don't compare the charge. This is a tremendous trick I am all giving to you guys. Got it? So that here O minus, now charge, O minus is stable than C minus. Therefore O minus second structure is more stable than first structure. अरे I am telling you, ऑर्गेनिक केमिस्ट्री बहुत आसानी सब्जेक्ट है बेटा. आसानी सब्जेक्ट मतलब आसानी तरीके काम करना है. डोंट कॉम्प्लिकेट इट. सिंपल पॉइंटर एटम में लगा दो एंड चेक द नंबर ऑफ इलेक्ट्रॉन्स, चेक द इलेक्ट्रोनेगेटिविटी. इलेक्ट्रोनेगेटिविटी, चार्ज, ऑक्टेट, वी आर डूइंग द सेम थिंग. आई एम नॉट टॉकिंग अबाउट any kind of interior of complicated technical terminologies. है ना बेटा? यस, हाँ हाँ यस. और एक क्वेश्चन कर दो हम. अरे ये नीट 2025 स्टेप अप प्रोग्राम है. सो इन दैट कॉन्सेप्ट भी दिया जाएगा, क्वेश्चंस भी करना है, एंड आई एम मेकिंग द स्टूडेंट टू डू द क्वेश्चंस. हाँ यस. अरे इट इज वेरी इजी. आई एम मेकिंग यू इजी. I said you all, many students said you all have so many doubts in resonance, but that is for today, and after my class you all say this is the best organic chemistry classes you all are experiencing, right? Okay, come on. और एक थोड़ा सा आगे बढ़ेंगे. और कुछ questions here? हाँ. Now, in this one more example I just want to discuss. स्ट्रक्चर 1 कार्बोकैटायन, स्ट्रक्चर 2 कार्बोकैटायन, कौन सा स्ट्रक्चर आपका ज्यादा स्टेबल होगा? कौन सा स्ट्रक्चर ज्यादा स्टेबल होगा? नो स्पैमिंग. Yes, the question is for you at the end of the session. After this question discussion I am going to close the session. Okay, get ready. So अगर आप कुछ काम करने जाता हो तो काम होने के बाद आपको कुछ भी ना कुछ मिलना चाहिए ना. So we learn concept, we have to apply it and we have to get the answer, है ना. चलो, structure 1 is more stable than structure 2 or structure 2 is more stable than structure 1? Or one more unknown came na. Okay, Abhinav, he is a competitor, he is your competitor. Come on, who is the more stable one? If your answer is 1, you just put 1. Yes, that's my pleasure to explain, Fatima. It's my pleasure. Oh, sorry, Anirudh. Okay, sorry. Ishta, you want to say 1? Okay. Talking. Okay, if it is 1 or 2. Thank you. 1 or 2. Jaldi. 1 or 2. Now, in this case, carefully you see, it's a carbocation. Carbocation and oxygen. Oxygen is having negative inductive effect because oxygen and carbocation separated by 2 sigma bonds, not 1 sigma bond. If 1 sigma bond is there, carbocation and oxygen is separated by 1 sigma bond, उसमें resonance होगा. If resonance is there, okay, so resonance is there. Because of the resonance, this electron pair goes there and make this carbon positive charge so happy. Therefore, carbocation is unstable because of negative inductive effect. Carbocation is making more stable because of resonance. उसमें कुछ ग्रीक एंड लैटिन नहीं है. स्टेबिलिटी 2 इज ग्रेटर देन 1 क्योंकि रेजोनेंस है नहीं है, सिर्फ ये देखना है. सो ए कॉम्प्लिकेटेड क्वेश्चन, ये सिंपल कॉन्सेप्ट इस्तेमाल करके आप आंसर दे सकते हैं. फातिमा, ओके. सुभश्मिता, ओके, यू सेड 2, योर आंसर इज परफेक्ट. योर आंसर इज परफेक्ट, है ना. एंड नाउ वी आर कमिंग टू, हो गया. सो you avoid confusions, my dear students. Okay, talking about here, we completed today resonance, and tomorrow we are going to step into the mesomeric effect. Okay, this continuation of tomorrow's class is very, very important. Then we apply inductive effect and mesomeric effect together, and also will give a short glimpse of hyperconjugation, which was actually completed a long ago. Okay, beta? And at the end, I request you all guys be regular in the session and be practice. Join in the Telegram channel that is given to you guys, and please like, share, subscribe the sessions. Thank you very much. God bless you. फिर मिलेंगे कल. Bye bye.